Okay, welcome to this second lecture in the data science lecture series. Today Prof.dr. will give a presentation. I'm sure it will be very exciting. This is, as I said, the second lecture. Here John gave a talk, I think 2 weeks ago. I think in 2 weeks' time Bettina will give a talk. And there are many excellent speakers lined up, let's say, until the end of the year. Also, for the people that were not here last time, I would like to remember that on the 4th of December, there will be the Data Science Summit, where I hope that all of you will be there. But let's now switch to the menu of today. So Prof.dr. is a very close colleague. We are, let's say, just one door apart from each other. He studied and worked in Antwerp. He was at Bell Labs for a few years. Then I think in '89 he came to this university. The name of his group has been changing over time. It is now called web engineering. If I talk about Paul's hobbies, he is a fan of music. He likes to print things in 3D. He also likes to make photographs. And another hobby is that he likes things to be very much adaptive. If you look at his career, he started very much as a database researcher, then he moves to hypermedia, and the last couple of years he has been very much talking about adaptability and adaptivity, also in the context of data science. So the floor is yours, Paul, and let's give him a warm welcome.
All right, let me start with a brief word of warning. I have a bad cold, so if I sometimes have to sneeze and cough, right, that's not because the presentation isn't going well, it's because of my health. I will talk today about how and why we have to move from what we call expert-driven adaptation, where experts determine what a system should do, and specifically in adaptive systems, towards data-driven adaptation in order to be able to serve the world population. What I'm presenting today, right, is research-based opinions, right, of myself. It does not necessarily represent the view of the Data Science Center or the TUE or any other body, right, you might think that I represent. I will start with some wise words. They are actually attributed to Plato. Wise men speak because they have something to say, and fools because they have to say something. You can use this to your advantage. If you don't like my message, you can always say that I was just here because I had to say something and it doesn't mean anything. So it's up to you to decide which of these it is. I'll give you another warning, serious warning. Maybe the room isn't completely full, but maybe it'll be emptier after the following warning. So this talk actually touches upon religion. It's a sad truth that over 85% of the world believes in expert-driven adaptation. Not all the same expert, right, but you believe that there is some expert that tells you how we should adapt to the rules set forth by that expert, but only 14-something% believes in data-driven adaptation, where we humans will collectively decide what we should do. This will repeat itself throughout this talk. If you are an avid supporter of expert-driven adaptation of one of these kinds, you may not like the talk. You have the ability to leave now, but please, if you stay, don't shoot the speaker. The most adaptive system that we know is the human. We will do a quick experiment for which I need a volunteer. And I've already appointed a Chinese volunteer to try on this one-size-fits-all bathrobe. About 10 years ago, the management of the TUE decided that it was a good idea to include in our Christmas package, the Kerstpakket, a bathrobe that would fit all the TUE employees. Yongming cannot really conclude that he doesn't belong at the TUE because he wasn't there when we all got his bathrobe. So maybe later other sizes were acceptable, but 10 years ago you would not have fit the profile of a TUE employee. I have tried this bathrobe with many people, including myself, and have yet to find someone for which it is a perfect fit. Now, we are used to adapt to circumstances that do not fit us very well. You may recognize what's shown in this picture. These are the pedal trains in the Efteling. And the pedal trains are actually not one size fits all. The makers have decided that children need to be under a certain size to be allowed to ride the trains. But there is an escape. Some children are too small to reach the pedals, and those are allowed to have an adult ride with them. And I can tell you that as an adult it's a painful experience because your knees hit the train all the time as you are pedaling. So, okay, these circumstances do not fit at all. In some cases, there is little we can do about it because what doesn't fit us may be defined by a standard. We may just not fit the standard. Sometimes it is because of some kind of dictatorship or of hippo management. I don't know whether you know the term. It's the management that makes decisions based on the highest paid person's opinion. Clearly, the bathrobe was a hippo decision, and any data-driven decision, right, would have concluded that just using one size for all the TUE employees was a really bad idea. Democracy is actually something that, if implemented correctly, can tip the balance. Democracy is an attempt to use data-driven adaptation to our society. We will see later that it doesn't work very well at that. All right, let's start with an example of how to do personalization. This is a typical example of one-on-one tutoring where the master is teaching something to the apprentice and the master knows all, right, and essentially explains a procedure to the apprentice. The apprentice follows the instructions, but if something goes not according to plan, the master can immediately adapt, right, the teaching to suit the individual student. So this is actually a very nice approach. Unfortunately, if we implement this on a large scale, it becomes prohibitively expensive. We may have enough masters, but we don't have enough money to pay. So the solution, of course, is to use ICT to implement that personalization. We cannot pay humans to do one-on-one tutoring, but we can certainly create computer programs that take over that task. Now there is a problem when experts, like the master in here, has complete control over the process, and I will show you one example that was pointed out to me by Mikola Peshinitsky. It's an example used by Ron Kahavi a lot, from Microsoft Research, doing a lot of tutorials. And it's an example from medicine, and so no data scientists involved. That experts can be really wrong. And experts tell you what is the best procedure to follow. Well, a well-known example from history is that if you want to cure any number of diseases, I have a long list in my notes here, right, acne, asthma, cancer, cholera, coma, convulsions, diabetes, and the list goes on and on. All these diseases can easily be cured through bloodletting. If you cut open a vein, the disease, where it means that you have toxins in your blood, just let out some blood and you will be cured. This can be done by cutting open a vein. It can also be done by using leeches. Right? And in the 1830s, the French, for instance, imported 40 million leeches a year, right, to essentially do bloodletting. By now you may already have reached knowledge that says that bloodletting is perhaps not the right cure for all. But how do you act, right, when the experts say that bloodletting is the right approach? Well, that's where data science comes in. You have to rely on the data. And Pierre Louis was one of the first data scientists in medicine who did a controlled sort of A/B testing procedure. So it's one of the first clinical trials. What he did was, he divided the patients, in this case patients suffering from, I believe, pneumonia. He divided them into two groups. One group was subjected to bloodletting, and the other group received any number of other treatments. And then it's a simple procedure in data science. At the end, you count the bodies, right? How many people actually survive. Right? And the number of bodies were stacked up higher over the bloodletting sink. And such controlled experiments can now be done at much lesser expense, both in terms of money and lives. Right? On the web, we can do controlled experiments cheaply to find out which principles, which techniques, which adaptation works the best. All the big internet companies, think of Google, Microsoft, they all do that. Right? They do online tests that you may not notice as a user, but they try different approaches at giving you the best possible advice, recommendations, and they look at which recommendations work best. Like they, for instance, they give you adaptively selected advertisements, and they will see which adaptation strategy leads to the highest click-through rate. So to decide how to actually help people using this method. We can apply this, of course, also in teaching. And so get rid of the classroom model where one expert, the teacher or the preacher, like, is talking to the whole class like I am doing today. Using a one-size-fits-all approach, you all get the exact same story. And there is a little bit of room for feedback at the end, but by that time it's too late to change the story. The tutoring model, it's one-on-one, interactive, with tutor and student, and it's very expensive, but it allows this personalization. So what we need to do is to automate that personalization. And we can do this automation in an expert-driven or data-driven way. We will talk about that later. So one thing is very clear, that the current generation of MOOCs is a very bad idea. Right? So if we were using, right, our scientific expertise, technology will work. Here's a simple picture, initially created by Peter Brzezinski. It's very simple. Oops, I'm going too fast. The system will collect data about the users. That data is transformed into a more usable model. We call that the user model. It represents what we know about the users, and then the users are able, the user model allows the system to generate adaptation. So when you issue a request to the system, the response from the system will depend on what the system knows about you, what you have done before, right? And that is all recorded in your user model. A nice example of such a system that we created in a project called CHIP that we did together with the Telematica Institute and the Rijksmuseum resulted in this art recommender for the Rijksmuseum. We created the adaptive technology, actually Natalia Stash, who is in the audience, I believe, created the technology for this, and then a company actually created the graphical design because they didn't like the nerdy interfaces that we designed earlier. So it looks nice, right, but the functionality is exactly the same as what we had with a different interface before. The first thing you do is you are presented with this carousel of very different artworks, and you rate the artworks. You say, oh, I like this painting, or I don't like this painting. And then the system will deduce what it actually is that you like. So when you like this painting, you may like the type of technology used. It is probably oil on canvas. It may correspond to an artistic style of a certain area and certain lighting techniques and everything. And you get topics that are recommended that represent like what's on the painting, what's the technology, who is the artist involved. And you get also other paintings that are then recommended that you can also start rating. And when you explicitly rate topics, then they appear at the top right, either all your recommendations or the ones where you said I like it and the ones where you said I don't like this. So you can rate topics and they are then listed there. So what the system knows about you is actually also displayed, and in fact you can alter the idea the system has about you. So this is the loop that we started from, but now the loop has been extended with what we call scrutability. The user, and perhaps also an administrator, is allowed to edit aspects of that user model and provide additional data also about the user himself. This scrutability becomes essential because the law is increasingly requiring it. We have the right to know what the Googles and the Facebooks of this earth have registered about us, and we can also explicitly ask them to make corrections. Now, we're not allowed to have them correct just anything we want. Fortunately, right, the law still allows us to decide what the students' grades are for exams, even though that is, of course, user model information. The students do not have the right to tell us that the grades should be different. Right? We still have some say over parts of the user model. But in general, users can ask this, and they can even ask the system to change adaptation, and for instance, to not show certain search results that the user may not like. Right? Typically, criminals do not like their criminal activities to be listed in search results by Google. That's now all arranged by law, and the systems need to take that into account. Okay. When we create such adaptive systems, we typically follow an architecture that we studied quite a long time ago. Hongxing Wu had this picture in her PhD thesis, where we concentrate on the middle here, where we no longer just have in websites a domain, whether the website deals with, but we store explicitly a user model, and we have an adaptation model that combines them. And I will talk about these a little bit in the next few slides. So what is the domain model? The domain model deals with what an application is about. Typically, we call this concepts. And these concepts or topics are often predefined. Someone creates an application, like a teacher is designing a course, or a museum curator designing a website for the museum, and decides which topics am I going to include in my site. Which topics are we going to cover? Or also an online shop, I will decide which products to sell. Or a site that offers discussion groups, like one of the sites that I regularly visit is DP Review about photography, and they have a fixed list of topics that you can discuss, typically arranged by manufacturer of equipment. Sometimes topics may be defined but not necessarily predefined. Like a news site has to just follow the news that is happening. And maybe news about the new topic area is showing up, and then the site provider needs to adapt the structure of that domain, needs to adapt the topics that are there and add new topics. And sometimes we cannot follow that as a designer, but must deduce them automatically. What are people talking about on Twitter? This changes so rapidly, you can't really have a designer try to follow that. we need automated methods to deduce what people are talking about on Twitter, and such research now not only includes the detection of topics, but also of, for instance, opinions. Are people talking about, say, Philips, right, in a positive or a negative way? Or if you have a specific new product, right, what do people think about it? Do they like my new product or do they not like it? You want to find out all of that automatically. Now, what we have done in the CHIP project, for instance, is to enrich the domain model defined by a curator who says, like, we have these and these and these paintings, and provides information about these paintings, who is the painter, such, right, is to add a number of other databases that allow us to reason about these data. Like an artwork has a subject, but we can have a hierarchy or a network of subjects. Something is a broader subject than something else. Same thing with places, for instance. Amsterdam is in the Netherlands. And so if something is tagged with Amsterdam, you can deduce that it is also tagged with the Netherlands, even though that wasn't done explicitly. Same with creators of artworks. A painting was painted by Rembrandt. Then maybe if you like the paintings by Rembrandt, you may also like the paintings by Peter Lastman, for instance, who was the teacher of Rembrandt. So having these databases, sometimes with linked open data, sometimes with linked data that is not open but commercially available, allows us to reason about the selections the user made. Just like we selected, we said, oh, I like this painting, and suddenly I got recommendations for painting techniques and for artists, even though I didn't say anything about those. Now, this type of connections that exist in the adaptation model, can be used for adaptation to infer, for instance, that you probably like paintings by the teachers of the painters of whom you like the paintings. But we can also add connections that are explicitly geared towards the adaptation. For instance, to say A is a prerequisite for B. To say you should study A before you are ready to start studying B. And this is often defined by an expert. An expert says, well, if we're teaching math to small children, they must first learn about addition before they learn about subtraction. Makes sense? Probably to everyone here. It's an expert that decides that. It's not always that clear, right, whether experts get the adaptation right in all cases. It gets complicated when it's not just a matter of selecting, oh yeah, you should study A before B, but maybe it also depends on something for instance, your cognitive style. Some people should be recommended to do A before B, and for other people it doesn't matter because they can handle it in a different order as well. So it becomes a difficult decision process that we can better do in an automated way. This adaptation only works if we know who the user is. Here is a very well-known cartoon from the New Yorker. It actually dates back over 10 years. It dates back 21 years actually. When it was more or less true that on the internet nobody knows you're a dog. Today, well, better think again. I'm sure Google knows that all of you are not dogs. So, how do we do that user model? That's the question, adapt to whom? What do we know about our users? And this cartoon actually shows the two most important aspects of that. There are things that we actually tell the system, right? We go into the confessional and we tell the system something about us. What we typically do in an adaptive system is we tell it who we are, what our background is, maybe what we studied, our age, our gender. We provide a lot of information. Perhaps there is a selection of possible interests, so that the system can overcome what is called the cold start problem. It's hard to start adapting to a user you know nothing about. So people try to solve the cold start problem all the time. Now, the system also monitors what you are doing. And so, in many cases, when you say something about yourself, the system already knows, yeah, we already know this, or you are lying, this isn't true. And the system often knows better, because it observes everything you do. So we do the same things in adaptive systems, and if as a user you don't like this, but you still want to get some form of personalization, the only thing you can try to do, and we have technology in place for that as well, is to do what we call client-side user modeling. So we're interacting with the web, but everything about ourselves, right, we store on our client machine. This is becoming possible nowadays with, for instance, the client-side or the browser-side storage, where a browser can actually use the structured database on the client side, which unfortunately with current technology, that database can still be requested, right, and read out by the server in the same way that the server tells it to store something. So if you are browsing anonymously and doing the client-side storage thing, you can limit the amount of information that the server has about you, and to some extent, right, only reveal about yourself what you explicitly want. There is also a body of research that tries to detect and prevent unethical adaptation. A lot of information has been gathered over the past decades, right, and adaptation being performed, adaptation like decision making on like who gets a mortgage. Right? And then we have legislation in place that says, well, when you're deciding on mortgage, you're not allowed to discriminate based on gender, based on race, etc. And so, although in the past this was done, and we have large databases of decisions and whether these decisions in the end turned out to be the right decisions, like we approved some mortgages, we disapproved other mortgages, did the mortgages that were approved actually get paid off? Were these good decisions? Well, they may have been good decisions from a financial point of view, but maybe unethical. How can we now make new decisions using the old data, but how can we guarantee that we don't repeat the discrimination that was in the data before? This is harder than you might think. Just eliminating attributes that are now forbidden from the database is not enough. Toon Kalders, who used to work in our group and is now a professor in Brussels, studied this together with Faisal Kamiran, who now moved to Saudi Arabia, I believe. Now the third part, how does the adaptation actually work? The main challenge in adaptation research is how to define or to use the desired adaptation automatically once we know the domain and the user model. Now there's many ways in which adaptation can be done, right? Can be made visible to the end user, and one of our former PhD students, Evgeny Knutov, designed this taxonomy. You're not supposed to be able to read all of that. A huge taxonomy of techniques that are being used by different adaptive systems, mostly research systems, some actually production systems. You see there's a lot of techniques, there's a large body of research on performing adaptation. I will only highlight just a few things by using the PhD student of another, PhD thesis of another student of us, David Smits, who designed and built the Gale, the Gale adaptation engine, originally called the Grapple Adaptive Learning Environment, and then after the Grapple project was finished, we renamed it into the Generic Adaptation Language and Engine. And even though I have sometimes criticized the HIPPO management, the HIPPO management of the TUE has made a great decision by allowing David Smits to actually produce the first adaptive PhD thesis in the world. Meaning that there is no booklet. This thesis only exists in digital form online served by a server that does automatic personalization as you read the thesis. And we see some of the adaptation being done, like what I did to show this screencast is the screenshot was I went to introduction and then immediately to discussion. Now, something that every PhD thesis has in common is that it poses research questions. And you cannot understand the discussion if you don't know what the research questions are. So there's been a prerequisite that says, well, the research questions are a prerequisite for the discussion. But they're not a very serious prerequisite, so we're not locking you out from looking at the discussion, but we have this inset that describes the research questions as something like a sidebar that you often see in magazines. In magazines, there is a story, and then there is a grayed out area with some additional extra story that you can do without, for the most part. In this case, you cannot do without because it is a prerequisite. Right? But so the questions are briefly represented here. And that's an adaptive technique. The other adaptation that you see is the adaptive menu. The sub-menus automatically open and close as you select topics. So it's this has what I find is a really interesting name. Right? The standard name, I did not invent this, but this is called an accordion menu. And what the other thing that we see is that some of the links are blue and some of the links are purple. That's standard. Every browser, every website you go to, the links are blue or purple, and purple means you visited them. That's correct. The fact that you visited these links before, that's historical information about what you did. That's part of your user model. So, in fact, what happens here is the links are shown in blue or purple, depending on whether the user model says you visited them or not. And we can, of course, do adaptation using many more colors. And in fact, in the thesis, blue, purple, and a darker purple, and black and orange, all these link colors are used for different purposes. And there's other bits of adaptation that you might not even have noticed, but there are these black lines, where the black lines indicate which content on this page is new since the last time you read this page. And so also that bit of adaptation is there. And there's another bit, this is not such a nice screenshot because I just took it with my camera. Another screenshot, this is again a page from the thesis, but this is what it looks like on a mobile device. And we see that the layout is adapted. The menu now appears at the top, and there was also a next topic button that now also appears at the top, and then the page is below that. So you can just scroll up. But there wasn't enough space on the mobile device to put the menu and the text next to each other and still have enough text left. So that's how it's adapted automatically. Right. All this adaptation that you see in the thesis is a case of expert-driven adaptation. David has actually written all the rules that define how his thesis adapts to the reader. Depending on the type of reader, you can say I'm an expert or I'm not an expert, and you can also say I'm a reviewer of this PhD thesis, and so I don't want to see any adaptation, I want to see everything. That was, of course, a requirement by the board of the university that the reviewers of the thesis should see everything. We actually wanted to have some sort of magic, what is it typically called? So this a bit of magic functionality that through some sequence of selections, Easter egg, yeah. So the thesis has no Easter egg because putting an Easter egg in but hiding it from the reviewers would be a violation of the rules set out by the board. Okay, expert-driven adaptation. Well, the simplest case in which we see that systems are reacting automatically is not adaptation, but it's just automation. A certain action results in a certain reaction. The standard case that is adaptation is that the reaction depends on a combination of the action the user makes and essentially everything the user did before, the complete user model state. Now, of course, every adaptation rule we write only looks at some specific variables. Like a prerequisite looks at what is your knowledge about a specific concept to decide whether a specific other concept is now recommended, yes or no. We don't look at the entire user model state all the time. Now we can go a bit further, and an interesting challenge towards the future. Can we make the system learn how to react on the combination of what the user does and what we already know about the user? So instead of the expert defining the adaptation rules, can we have some of that automated? Well, there's two approaches, and they have been used extensively in the past. One is what I call data-driven adaptation, and it is item-based or content-based. What you do is you create a rich model of your application domain and have all kinds of relationships so that you can decide if the user has bought this object, which is very similar to this other object, the user is likely to buy that other object as well, and so we can make that recommendation. This type of content-based recommendation has been used, for instance, in that CHIP project. The recommendations you get about the artworks of the Rijksmuseum are based entirely on what you did, combined with everything that is known about the objects. These linked databases are used to reason about the data and to decide that maybe when there are certain connections between different artworks, you will probably like the second artwork if you liked the first. This is a very useful method, mainly because in most cases the knowledge about the domain is very stable. The collection of the Rijksmuseum is rather stable, and the connections between all these objects are extremely stable. It's not very likely that next year someone will say, no, Peter Lassmann was not the teacher of Rembrandt. No, this relationship now changes. No, it's very stable. And so we can make very stable recommendations. Another approach is what we call data-driven adaptation, that is user-based. It can actually also, to some extent, be item-based, but we actually look at the behavior of different users. And so we look at, okay, user A is buying some products, right? And if user B is buying the same products, we decide that these users must be similar. And if they like the same things, they are probably so similar that if for the first person we know that he likes it, or if the second person, we know that he also likes or also bought this third element, right? Then it's a good idea to recommend that to the first user as well. Note that in this case, if it's purely user-based, and we don't use semantic databases about the objects at all, we don't actually need to know anything about the products. We just look at who likes or who buys these products. This can seriously backfire. And there has been an incident years ago where suddenly people who went to the Amazon website and bought the Anna Frank diary, they got a recommendation to maybe also buy Hitler's Mein Kampf. Some people thought that this, in hindsight, was not the best possible recommendation to make. But not knowing anything about any of the books in the store, besides the buying behavior of the user, this seemed to be a reasonable choice after a number of people apparently bought both books at the same time. We see similar types of recommendations, and sometimes it isn't even clear how the recommendations are being made. Nowadays, when you go to YouTube, for instance, it will start with lots of recommendations. Oh, recommended movies to you. And sometimes I wonder, why are certain recommendations made? And all that YouTube is willing to sometimes tell you is, we recommend this movie because you also watched, and then a completely different movie, where you think, I don't know what the relationship between these movies is, but if YouTube thinks they're similar, there must be something to it. Right? And then, of course, the worst thing you can do is to then actually watch that movie, which will only reinforce YouTube's belief that these movies are related. What can we do to improve the situation? Well, something that has been tried and that sometimes works but doesn't always work is, let's fire all the guns we have. There is so much data available, let's use everything. Right? Let's use content-based filtering. We have so much metadata and semantic databases available. Let's reason all we can about the topics. Let's do collaborative filtering. Let's look at how users use it, and let's combine all of it. The problem is that in a number of cases, this doesn't really help. This was, for instance, tried in the CHIP project, where the content-based filtering was somewhat disabled. Let's try an experiment with collaborative filtering. It seemed to work also well. Let's combine both, and the result was zippo, right? And no improvement anymore. So you have to really choose, really pay attention to deciding what is the best approach. Also, if we're using data-driven methods, what are the best methods, algorithms, right, to draw conclusions from the data that we have. Joachim van Schoren in our web engineering group has developed OpenML, mostly before he actually joined the group, but there was a good reason for hiring him, where you can submit your data set, right, and then ask the system to find the best algorithms for drawing conclusions from that data set. Adaptation also involves a danger of what we call over-specialization. Recommender systems and adaptive systems become better and better at doing exactly what you want. Like a news filter becomes much and much better at only showing you what fits your profile and at leaving out everything else. The problem, of course, is that it can only learn what you are interested in through examples of what the system has. Right? You cannot tell the system you are interested in something the system doesn't offer. And so, as a result, just to name a fairly extreme example, like I'm interested in accordion and in photography and 3D printing, and if I have a news site that will show me, based on my user profile, what is happening in the world that might interest you, I might not get a news message that large airplanes are flying into buildings and the world is now changing completely, because it has nothing to do with photography, 3D printing, or accordion. Right? Yet, I would have been interested in that news, but couldn't tell the system because that type of news hadn't yet happened. Right? So that's a problem. Recommenders need to think outside the box, and that is, of course, also a point of research in the large companies like Yahoo, Google, and such. They published also articles on how to still surprise users with something they are interested in, even though they haven't explicitly said so. And then we have the very difficult problem of adaptation scrutability. So some researchers have, for instance, requested Facebook to deliver them their user profile. What do you know about me? One of the first guys was someone from Austria who actually had a lot of trouble and had to threaten with lawsuits to obtain the material that he was legally entitled to receive, and in the end got a huge stack of paper. Actually, he got DVDs, but we printed it out, it was a huge stack. And then some researchers in Ireland repeated that, And the average, I believe, over 50 researchers was over 1,200 pages each. But these were not heavy Facebook users, but Facebook has a lot of information about you. And, well, maybe you can scrutinize all that and say, well, this is indeed what I did, but this is all correct. Now, if you get recommendations that are wrong, how can you, first of all, tell the system that I'm not getting the right recommendations, even though everything you know about me is true? And it's also hard for the suppliers, right? If I develop an adaptive system, I put it in the market, right, and I have the right information about the user, and they tell me you're not adapting in the right way. That doesn't really tell me how I can change that. Right? So that's an ongoing research area, a serious problem. Right? You can't currently tell the systems, right, how to improve the adaptation. You can only tell them something in my user model is wrong. Right? You can't help them to change how they actually use that. Right, to sum it up, this whole research started essentially with two apostles called Peter and Paul. You see this picture here of the door of St. Paul's Cathedral in Rome, where we reenacted the scene depicted on the door, where Peter and Paul almost shake hands. They didn't really shake hands because they never met. Right? We actually could shake hands, but we and then didn't. That's how it started. We started expert-driven adaptation. I've been leading the UMAP area and the user modeling organization. The future goes towards meta-adaptation. Data-driven adaptation is, well, if we can observe what people do, and if we say that if many people read A before B, and few people read B before A, then A must be a prerequisite for B. We can deduce that automatically. But what are good values for many and few? Okay, so that becomes meta-adaptation. Right? Let's optimize these thresholds for many and few automatically. But we can go further and we can observe certain navigation patterns on a website and then try to decide, should we start recommending that pattern to other users? So that's already a more general problem, and we can continue and start giving the systems more and more freedom in deciding for themselves how to optimize the way in which these systems adapt. This is one of the goals we have in the Impulse 2 project that we are hopefully going to start with Philips. And nothing is certain with Philips, especially not when they decide to split up the company, so we'll hear about that. But the idea there is that with connected devices, we currently don't really know how to give users advice based on their behavior, and this meta-adaptation is the way towards that. Where will it end? Well, ideally, when you base everything on observed behavior, you will end up with a real implementation of what we call the wisdom of the crowds. Now, there are cases where the wisdom of the crowds works really well. A famous example is like you get to guess the weight of an ox, right? And then like 1,000 people guess the weight of an ox, and then you take the average of all the numbers, and it's a very precise estimate. Now, it also seems that democracy is something similar. Everyone gets to vote, so we must end up with the right government. The problem is, and this is well known, of course, in data science, is that such approach only works with what is called the independent learners. Right? If you use an ensemble of experts that are learning certain behavior, they must be independent, otherwise this becomes an illusion. Now, what do we typically do in democracy, for instance? That is that in the months leading up to election, all the politicians spend a lot of effort breaking the data-driven approach, trying to break the independence of the voter and try to convince them to vote in a certain direction. The result is That's not a term that I invented, but the result is you don't get the government you need, you get the government you deserve, right? By letting yourself be influenced by lobbying and such. And so that's unfortunately how it works. But what if we do it right? When we leave the reasoning completely up to the systems? Well, what can happen if we believe Hollywood as experts in predicting the future in science fiction movies? It always ends with a doomsday scenario where computers come to the conclusion that the world can be optimized by ridding the world of humans. It is very likely that they are right. So in order to prevent that, we must restrict what we allow automated systems to do. And we already see some of that restriction. Right? It's already built into the law. Even Google is not only allowed, but sometimes required, right, to remove search results that are the result of the correct data-driven implementation of their algorithms. Right? When you give the right search words, the correct answer may be child pornography. But you're not going to get it, because they're not allowed to do that. And you're looking for certain criminals, and you don't get the information because they have requested and been granted the right to have these search results removed. And sometimes you request for something, and no, this is a copyright violation, where you're not getting that either. And so results are being manipulated already at this time. Concluding, because we are running out of time. Many people say that data-driven adaptation is the future. I'm one of them. However, we need to be careful. We need to implement data-driven adaptation in a correct way so that we don't actually end up with expert-driven adaptation of which we think or believe it is data-driven. If we want data-driven adaptation, it should be real. Otherwise, it's just like management. Right, where the typical hippo management, where the managers also try to convince the employees that their decision is actually what the employees want. It's also like democracy, right, where political parties try to convince you that their point of view is what you actually want, so that you can vote for them. There's been lots of research on manipulation. I took this image from a blog that, for instance, said that, well, if you want to boost the likes, right, on like in Facebook of a page, having some fake likes helps a lot. But they also found something quite surprising, that is that if you add some fake dislikes, it also results in a higher number of likes. People tend to be positive. And they tend to not like the fact that people are negative about the site, and they'll start liking it as well. So it's a very strange behavior. It's best to leave data-driven use in online adaptation into its pure form, right, and not try to manipulate it, because who knows what we end up with. Time for some questions. While you look at the questions, I will first show you here this list of a large number of projects that we've done that deal with data science, starting from early adaptive systems to data mining research, through the new Impulse projects that are currently running. Questions?
That's thank Paul. Questions? So perhaps I can ask the first question so that people get some time to think about it. So what's the scope of what you are talking about? It seems that many of your examples are web-based, I would say customer or user-centric systems, but what if the systems has a physical component? And what if the systems have multiple stakeholders? For example, if I go to a hospital, I have patients, I have nurses, I have doctors, I have management. So the system is, there are multiple stakeholders, so what the user model is not so completely clear.
Yeah, Okay, so in the physical world or in the hospitals, it's not all that different. There is research that deals with the aspect of trying to adapt the overall performance of a system, not just the performance for a single user. Right? And the examples that I showed is we try to optimize the interaction that a single user has with either an online course or a shop. But there is also a global goal. If we, for instance, try to optimize how traffic flows, right? We are not creating the best possible route for every driver, but we're optimizing the overall throughput. And the same happens with a hospital. We try to optimize a hospital not so that you get the fastest treatment, but so that the largest possible number of users get the best or the fastest treatment. So the adaptation goals there are different because they are collective goals. And of course, optimization then becomes a very different question, right? But again, can be data-driven in its solution.
Yeah?
I have a question. I used to work in the knowledge-based systems industry. 25 years ago, we were talking about neural nets. How does this compare with this kind of technology?
Yeah, neural nets indeed automatically try to optimize their outputs based on what they learn from the inputs, and in that sense they are a prime example of an adaptive system. They're still being researched today, and one of the current challenges and topic of current research, not that we do, but that others do, is the scrutability. The neural nets learn how to optimize their parameters so that the output satisfies certain criteria. And if you say, no, I don't like the output, or if you just say, like, okay, show me my user model, and say, well, we have these 350 parameters, and here are the numbers, right? They're all nameless.
Like a black box.
They're like a black box. And research is currently going on and opening up this to some extent because this technology is not allowed to be used if you cannot, at least to some extent, explain to the users what is going on.
Okay, thank you.
One last question? Yeah?
You just explained data-driven adaptation as opposed to expert-driven adaptation. But in the end, my conclusion would be that the data-driven adaptation provides so many rules that it becomes, in the end, an expert-driven adaptation.
Yeah, the system becomes expert, essentially, right? But the system doesn't become an expert that is dogmatic, right? Because it continues to learn from the data and will continue to adapt its behavior. But you are right that in some sense, by learning, it's the same way that although we think of ourselves as sort of expert-driven adaptation machines, we are very much data-driven. We learn, right from being a baby, we learn through reinforcement learning, right, what the commonly accepted behavior is. Right? When do we get punished? When do we get rewarded? Right? And we learn to behave in a way that conforms to the experts that try to teach us. And we learn that essentially in a data-driven way by means of feedback that we constantly get. Right? And yeah, and in the end we become expert. And it's the same with these systems that learn from the data and in the end become an expert again.
Okay, because of time, let's thank Paul again.